Okay, now I'm recording.
So on the website, where did you go to get that folder?
Okay, so that is under, get rid of that, get rid of that. So if you go to the Final Project tab, come right down here to Stirling Engine, Part Drawings and Data. And these are all the things you need to draw. Here's a cross section of the engine. And I even put some design information right down here. So when you put your engine together, if you decide to go with this style, and again, that's totally up to you. I want you to have some design flexibility in this. So you're going to take the two cans and you're actually going to push them together. The bottom can is going to have to swell a little bit with a press fit. So just assume that the cans overlap each other by 1/8 of an inch. That's what mine typically are. Okay. The crankshaft must have a power piston bend offset from the displacer by 90 degrees. And what that means, if you come over here, why is zoom always in the wrong place? Okay, see how this hump is vertical and then the small section is 90 degrees apart? That's what I'm referring to. So if the power piston bend, this one, is sitting flat on the table, this bend will be going up in the air out of the table. And then the bends should be 3/8 of an inch for the displacer, 3/16 going over to the balloon. And I show that here's the 3/8. So you can see that's going center line of here to here. That's your big bend. And then this 1/88, that's 3/16. And this is the offset bend for the power piston or the balloon. Okay, item 4, really, really important, folks. So when you do your Stirling engines, okay, you're trying to have a gas-tight seal right here. So if you come in with a pocket knife and you just slam a hole through that bottom can, it's going to let all the air out. There's going to be no seal to cause expansion and contraction and raise the pressure in this chamber. So in your baggie, I've included a little push pin that's undersized. And then what you'll probably want to do is put the push pin through here and then take the piece of displacer wire and just push it through ever so carefully so that you get a hole that's exactly sized to the displacer rod or the music wire. Okay. You're going to have two types of wire. This displacer rod is going to be the straight hard wire that I give you in your baggie. This rod, however, and this rod are some very soft stainless steel wire that you'll be able to bend easily. So if it's not the perfect right length, you can just put a little bow in it and that'll take up the extra length. Okay, so that's all the stuff I put out yesterday. Any questions on that? Are we all good?
Yeah, I had a quick question.
Yeah, shoot, Sam.
So you said like we should get started working on it here pretty soon.
Yes, absolutely.
So should we make every part as a different part and then we'll assemble them later?
Exactly.
Okay.
Yep. Yeah, so I mean, start modeling these pieces. You've already done your Coke can for yesterday's homework. And then tomorrow we're going to go over drafting, or we're at least going to start drafting. So then you can start making your blueprints for all of this stuff. Now, obviously, I gave you a blueprint. So you know, there's not a lot of thought involved other than the crankshaft. You're going to have to give me blueprints back so that I know how to make all this other stuff. We're going to go through all of that. But when you turn in your package in December, I want to see how I put every single assembly together. I want a detail print for every single part that goes in the machine. I want your grandmother to be able to make this thing and buy all the parts based on what's in your package. Okay, other questions, guys? Okay, I hear silence. Let's talk about the test. So, got through all of you guys' test. Does anybody not have their test back?
I don't think I got mine back.
Yeah, no, me either.
I don't have mine back from it, but I'm from the other section.
Okay. I thought I had them all back. I will double check. Maybe I just did the other section. But anyway, I got through one section and the average came out to be a 71. So yeah, a couple points lower than I like. I ideally like to target a grade average right in the center of the C range because C is defined as average. So, but it was not a total flaming bomb like I was expecting. So for those of you that did flare out, I will have to figure out something. Okay. The big mistakes that I was seeing, I saw a lot of people doing thin revolves, thin cuts, thin extrudes. People didn't have closed sections, so they would end up getting hollow balls, hollow pencils, that kind of thing. Did see some really nice work out there. Were multiple people that got 100 on it, so that was good to see. Yeah, there were some very highs and very lows. So, do you guys want me to go over anything from the test before we go on to the new material?
I just had a question on one of the threaded holes.
Yeah, Ryan.
So this one's on the exhaust hanger.
Yep.
On the pipe going like up and around it.
Yep.
So I see dotted lines on the inside. So I'm wondering how to tell that that was an outside thread instead.
Okay, so I was hoping that you guys would just think about it logically and say it's a piece of 3/8 rod, and if I put a 3/8 hole down in a 3/8 rod, I have no more rod. So number one, just plain logically, it didn't make sense to put a hole there. So that was the first thing that should have been a giveaway. The next thing that should have told you was exterior is, let's look right here. So I see the dotted lines, and that represents the bottom of my thread. If this were a hole, I would have a triangle right here where the drill point would be. So that was another giveaway. So between not having a rod left after you drilled it, not seeing the drill point for drilling it, I was kind of hoping you would get it just based on that. But that was a huge one. I mean, I would say more than half the class thought that this represented a hole. I only had a handful of people that said, oh, it must be externally threaded and he wants a nut on the thing. So, I mean, I didn't take off huge points for that. That was in the like 2-point kind of range. And then I
got more for that.
Yeah, you probably had some other stuff going on too. So the way I do it is I go by problem. So I'll list the exhaust hanger, and then typically mistakes are in the 2 to 3 point per major thing range. Because I always try to step back at the end of the grading, excuse me, think about the test, think about what you did and say, does it deserve an A? Okay, A means above average. I mean, got all the major concepts and just maybe a little nit or two. That's A work. B work, above average, all the major concepts, but several nits. C work, average, you might have missed a couple major issues, but really good effort. Okay, and you're average. D, you missed several major concepts. You got a bunch of stuff wrong, but you tried and it's not a total failure. And then F, you're out in the woods, you're just lost. And I got to make sure that when I'm done at the end of the day, that it makes sense. I tried doing a grading rubric before and saying 2 points for this, 3 points for that, and it ended up failing everybody. It just doesn't work if you do it nitpicky.
Could you open up those blueprints to the dog toy real quick?
Yeah, absolutely. Okay, what would you like to talk about?
No, I just got really confused because I swear I heard you say like multiple times to other people that there weren't fillets on this, and I got really confused.
No,
And then I lost points to fillets. Yeah.
Yeah, there's absolutely fillets on it.
Oh yeah, the R125 right there.
Yeah.
The R.125. Got ya.
Yeah.
I didn't see it. Okay.
Okay. Anything else on this one, guys? The cut revolve on the pencil threw a number of people. So I'm thinking that's probably partly my fault. Maybe I just need to hit that harder next year. Put some kind of a homework problem where there's a cut revolve. Wasn't hard, but it just seemed to throw people.
Yeah, no, I had an issue with it at first because I didn't realize that I wasn't bringing it out all the way, so it wasn't catching the edges of the hexagon.
Yeah, I mean that's simple, small stuff. Okay, anything else to talk about with this, guys? Okay, so if you do have any questions, if you do want to see it, I put all of the answers in the old exams folder, and in office hours, I went through all of this in gory detail. So feel free to watch the video of last week's office hours. All right, and if there's no questions, let's go on to new material. We are going to do the very last form of modeling.
Professor Abadessa,
Yes.
I do have stuff for engineers without borders if now would be a good time for that.
The floor is yours, Laura. Take it away.
Thank you. All right, so hi everyone, my name is Laura and I'm from the other section of the class. I'm a sophomore mechanical engineering major. I switched late, so I'm in this class now. And I'm here to talk to you a little bit today about the club Engineers Without Borders. What we are is we're a club of all different kinds of majors, but mainly engineering majors who come together and we work on projects outside of the US. We currently are finishing up a project in Honduras, and we just got a project last year in Guatemala. Our project in Guatemala is a 5-year project, and we're working on helping them fix their water tank right now. People came in last year, or not last year, they came in a long time ago to help this small village create a water system to get clean and filtered water to all of the houses in the village. But now their village has over tripled in size and they need to redo their water system because of all the old pipes, and they don't have enough to reach everyone in the community. So right now just started the project. We're in the early stages of design and filling out all of the paperwork for the projects. This is really good work experience for engineers specifically, because you're going to learn the entire design process and be able to apply what you're working on, especially as a first year. Right now you're taking very basic classes, and this is going to allow you to get a jump start on classes that you're going to be taking in the future. We have 3 groups. We have the design team, which is very engineering focused, and you're working on actually figuring out what we're going to do. We pair up with the Portland Professional Chapter. So we have, they occasionally will come to our meetings, and they'll actually help us talk through design and help us figure out what the best way to be to fix their system. And then we also have fundraising, which there you can learn how to write professional grants, which is also great to be able to say at an interview. And we also have the publicity team, which is my lead right now, where we're updating our website and social media and reaching out to other Engineers Without Borders chapters. We meet on Tuesdays from 7:30 to 8:30 on Zoom. How our meetings work is you'll get a rundown of everything that's going on in the club, and then you'll get to go into our breakout rooms, and then you'll be in a breakout room with your team, and you'll be working on anything that your tasks are for the day. Once we get past our brainstorming and paperwork section of design, we're actually going to be going into programs like SolidWorks and actually figuring out how to complete the project. Our first implementation for the project is coming up really soon. We're doing it before the end of October, and we have to do it remotely because all travel is banned. But next year, as long as we're able to travel, for the next 3 years, we'll be doing 3 more implementations, and there will be travel opportunities to go to Guatemala. It's a really simple process to apply for the travel opportunity as long as you're an active and participating member in the chapter. And we also have a lot of room for advancement if you want. At the end of the spring semester, we hold elections for design lead, publicity lead, fundraising lead, and then from there you can move up. We're also going to have a major part of our exec team leaving, so it would be great to have younger people, especially on this project, because we just started, and you know that you'll have a project through your whole college career, which is honestly a really good opportunity. And then so if you have any other questions, you can either ask now, or I'm going to drop my email in the chat, and you can shoot me an email and I can add you to our email list. And then if you want, you can look through, we have an Engineers Without Borders website through the UMaine system. If you just look up Engineers Without Borders UMaine, you'll be able to find it. And then we also have an Instagram, which you can reach out and DM, but it'll all end up going to me. So if you're interested or have any other questions, you can just let me know.
Where would we find the Zoom link to come to the meeting?
If you shoot me an email, I can put you on our email list, and then we send it out in the morning. And then if you ever want to be taken off, you can just also email the Engineers Without Borders website. We send it out every week so that everyone has it. You can also private message me or email if you want me to add you without emailing me. Are there any other questions?
Okay, very
Awesome.
nice.
Thank you.
Thanks, Laura. Appreciate it. Okay, on to SolidWorks. And today we're going to talk about sheet metal. Okay, this is one of my the pet things that I do that, excuse me, a lot of other sections don't do. But I do it because when I was out in the world, one of the first things that we put new engineers on is guarding, and it's almost always sheet metal. And it's really, really useful. So I think you should absolutely have it before you get out of school. So let's go over how to draw sheet metal. We're going to draw it as sheet metal. Then we'll actually be able to unfold it, so that you could generate a DXF file and send it directly to a laser cutter or a CNC machine. So it starts off a lot like any other part. I'm going to start off by drawing the base piece of sheet metal that I'm going to start working from. Okay, so I've got a rectangle. I'm fully defined as always. That never changes. Now I'm going to go insert, sheet metal, and base flange. That's going to be my starting piece of sheet metal. Okay. And I'm going to encourage you guys to come over here and click on Use Gauge Table. Because again, this is like the hole wizard. It's got all the information built in. So rather than you guys guessing and estimating, just use the stored info that's in SolidWorks. So we're going to select the table, and I'm going to use steel English units, probably the most common thing you could do. It's going to be steel air bending. Okay, down here, it says sheet metal parameters, 3 gauge. So if you guys go to Bangor Steel this week, and you want to buy a piece of metal, and it's sheet metal, you're not going to want to go in and say, hi, give me some 0.04 sheet metal, or give me some, 16th inch. They don't have it. There's no such thing. Sheet metal is done in gauge, and gauge is roughly 1 over the thickness, roughly. So for example, 16 gauge is roughly 1 over 16th of an inch thick. And let's go back, we'll look at the handouts, or excuse me, the class presentation. Okay, so when we talk about standard steel thicknesses, if you have 16 gauge, it's 0.0598 in thickness. So almost 0.06. Okay, 14 gauge, 0.0747. Okay, so it's roughly 1 over 14. So your really typical ones, the stuff that you can always get would be 11 gauge. So when people start thinking, I really want something that's about 1/8 of an inch, you can get 11 gauge at 0.1196. 16 gauge, that's always on the shelf, 0.0598. And then you come down to like 24 gauge. Typically, you're going to want to select the even numbers with the exception of 11 gauge. So like 24 gauge, 0.0239. This is the stuff that ventilation ducts and HVAC systems are made out of. Plenty of strength, but pretty thin and real easy to bend. The other thing to notice in the gauge table is that 16 gauge steel has a different thickness than 16 gauge aluminum. So don't get caught up in that. And again, I say just use the gauge tables in SolidWorks. It's got all this info built in. You don't have to think about it, and you won't screw it up like I did. Okay, so I'm going to use 16 gauge. And you can see, as always, SolidWorks gives us a prototype suggestion of what it's going to come up with. As I work off this flange, any bend I put in is going to get a default radius of 0.08 inches. Okay, that's all right. Or I could override it and put in whatever I want. Whoops. So I can change that if I want. This thing, K factor, sheet metal is really, really nice because it takes into account the fact that Metal stretches more than it compresses. Okay, so if I were to put a 1-inch flange on this that's bent, and then I have this piece of metal and another 1-inch flange, if I measure the center line distance through the entire thing, it's not going to be the same as what you calculate. And that's all because of what we call plastic deformation or stretching. So I've got my base flange. I'll say okay. Now I've got a little piece of sheet metal. Let's see, I will get rid of some of these planes and axes, clean up my screen. And now, if I want to, I can start putting bends in this thing. So I'll come back, insert sheet metal, and let's put an edge flange on it. So if I want to go up, I click on the upper edge, and it automatically draws a bend and a straight section for me. I can tell it how long I want this upper section right over here. So maybe I want a 1-inch section. You can do multiples at a time. So I'm clicking in the blue box and I'll hit shift on the other side. And I get another flange that's exactly the same height with the same attributes. I'll say okay. And I've got a piece of sheet metal that has 2 1-inch flanges on it. Now the cool part. So you can see right here, it created something called flat pattern. If I come to the one below it and I say unsuppress, it lays it out flat. And now I've got the pattern that I need to create before I go bend this thing. That's really, really nice. There's nothing worse than doing sheet metal layout by hand, but this will do it automatically for you. If I want to rebend it, I'll just suppress the flatten, and it goes back to the bent condition.
Or did you say put it to show or put it to roll back?
Neither. Okay, so click on the bottom flat pattern, hit unsuppress.
Okay, there we go. Yep, you're right. Okay, there it is.
Okay, and then I'll suppress the flat patterning. Okay, but you're not limited to, just straight flanges. If you want to get all kinds of fancy with it, we can do that. Let's come back into this edge flange. We'll do an edit feature on it. And we can do an edit flange profile right here. We'll put that down there. And now we're just working in the sketch that SolidWorks has already made. So for example, if I want to do something like that, I can modify the sketch and change it to whatever shape I want. Now I have that.
Wouldn't you have to define it again, though, after making those adjustments?
Absolutely. So one of the problems with the flange option is it doesn't fully define your sketches for you. You still need to go in and do that. So for example, on sketch 11, I would need to do something like define this height, define that height. Come on. There. So yeah, you got to go in and manually fully define the thing. And obviously, even though I've got one edge flange feature, I've got two sketches driving it. This other flange could be a different size, different shape from this flange. That's totally fine. And now I can come back in. Oh, that's ugly. That's really ugly. And now, as always, it's parametrically driven. So that's kind of fun. Let's get rid of this edge flange. There's a couple other options that are kind of nice. So if you get your flange going the wrong way, you can just click on the little arrows to flip it. Okay, so we can change the angle if we want. They don't always have to be right angles. The one thing SolidWorks is not smart enough to do is it will let you run material into material and do stupid stuff. So for example, if I add this edge and the opposite edge, oh, it's getting smarter this year. Last year it would run the edges into each other. This year it's smart enough to trim. So it automatically trimmed that out. You can set this gap if you'd like. But unfortunately, what you can't do is set it after the fact, which is, well, maybe they changed that this year too. Nope, same as it always was. But there you go. So you can put on multiple flanges at once. And that's what I need to scribe onto a piece of sheet metal and go over to the bandsaw or laser cut or whatever the case to get this shape. So this is really nice when you're doing electronic enclosures, stuff like that. Let me get rid of this. Let's do one where I actually close down the gap on those edges. So we'll do insert sheet metal, we'll do another edge flange. I'm holding down shift. Okay, so this G right here, this is the gap between your panels. So I'll make my flange distance 1 inch. And then by changing G, you can see it spreads out the gap or closes down the gap. That's really nice. Okay, you got a couple of different flange positions down here. So you can either start back and have the curve end right at the face of the metal. You can start at the face. So there's a couple different options for flange position for where you want the end of the bend to stop. And you can play with all those. I generally just use that one right there, the middle one. Works very nicely. And generally, I don't try to come in this close. You'll tend to get metal wrinkling right in here. So something like, 50 thousandths or a 16th of an inch. This gives me really good performance when I stay right there. And I say, okay. Now if I took this over to my welding guy, I could say, hey Fred, just go ahead and fill this with weld, and I could make a nice little watertight box. Maybe I'm making a maple syrup evaporator or something like that. It's absolutely where I would use something like this. Or in previous years when I've gone over sheet metal before the exam, there would always end up being a lawnmower belt guard come out of something like this. Okay, so now what I want to do is show you guys where the seniors commonly screw up. Start a new part. We'll start with a rectangle. Get rid of the extra junk, and let's show this. I cannot tell you how many times I've had students and junior engineers come to me with a design like this for an engine cover or something like that. And if you brought this to me as a manufacturing engineer, I would look at this and say, okay, I got to start off with a block of steel that's 1.25 inches thick. Then I got to come in with a cutting machine, cut all of this pocket out, and then I have to come in with a fancy electrical discharge machine, and I've got to make these nice tight square corners, and this would probably be, I don't know, a $1,500-ish part. And then the student looks at me and they go, no, I don't want that. That's more than my entire budget. And I go, okay, but did you want sheet metal? Yeah, I just want a bent box. Okay, this is not a bent box. However, we can turn this into a bent box. There is a sheet metal conversion function. So let's turn this into sheet metal and something that we actually can make for a couple of dollars. Okay, so we'll do insert sheet metal, and we're going to convert this box to sheet metal so we can actually flat pattern it. Again, we're going to use the gauge table, and I'm going to do English steel because that's what's locally available to me. I'll come down to 16 gauge. We'll do a default bend radius of 80 thousandths. That's pretty good. Okay, the first thing we got to do, we have to select a fixed entity. We got to tell SolidWorks, where do you want me to unfold from? So we're going to click that, and I'm going to choose the face inside the box. So this face is going to remain fixed in space, and then this flap, this flap, this flap will all fold down from it. Next, I have to choose my bend edges. So I got to tell it where the bends are going to be. I'll choose this edge, here, and here. Looking better already. And when I say OK, it adjusts the thickness, and it puts in the end gaps so that I can fold it down, and it creates these little corner reliefs so that the metal doesn't bunch up and wrinkle in the corners as sheet metal will often do. And now, when I come under flat pattern and I do an unsuppress, voila, I have a magic box that was created from a normally done solid model. Okay, so not super hard, just need to practice it, but really, really, really useful. All right, let's see what you guys have for homework. Since we have 2 minutes left. Sheet metal. Ah, yes. So we have an electronics enclosure with a feature array. Okay. So up here I've told you 16 gauge 1010 hot rolled carbon steel. Over here I gave you the thickness in inches, just in case you want it. And other than that, this problem tends to go quite easily. Okay, this is your G gap between the edges. And at this point, go ahead and get started drawing this, guys. So start with a base flange. And when you're all done, what I want you to do is make sure that your outside edges from the top of the enclosure to the bottom of the enclosure is 4 inches, and it's 3 from side to side. Okay. The 3 and 4 are not going to be your base flange size. So you'll also have to go in and do some measuring and subtracting so that you can adjust this and get it right. If you use the typical 0.08 bend radius, that's totally fine. I'm not going to get all crazy over that. Okay, so we are officially done with the class. I'll hang out for a few minutes, 10, 15 minutes, in case you guys have any questions. Otherwise, if you got to get off to another class, you're free to go. Thanks for watching.
I have a question.
Yeah, go ahead, Colin.
So when I go to click on the gauge table and click on the steel,
Yep.
it gives me a error and it says cannot access Microsoft Excel file. And
Right.
it says Excel file may be in edit mode in another window.
I'm getting the same message when I do it too.
I got this because I didn't have the Office installed. I have to download on my own the spreadsheet. But yeah, you can work on it. I think there is a solution on online.
The university provides Office. If you go to the IT department, there's a link to download it, like the whole suite for free. So I have it installed, but I'm still getting the message. So I don't know if there's like a component I have to download or a plugin or something.
Nope, nothing like that. The whole deal is I kept pinging you guys over the summer to make sure you put Office on first. Then when you install SolidWorks, it automatically recognizes that Excel is there. I'd have to do some Googling to figure out how to get SolidWorks to talk to Excel after the fact.
It's done. I did it. I don't have Office on my computer, but it works.
I was about to say this is weird because I didn't have Office on it when I downloaded SolidWorks, and I haven't had any issues quite yet.
Shh, don't say anything.
So for this part, you said we should use 0.08 for the radius.
Yeah, for the corner bends, sure, that's fine.
Okay. Mine defaults to 0.075.
Fine.
Okay.
I didn't spec anything, and it's not that critical. The only thing that's important when you're bending sheet metal is that the inside radius should always be more than one material thickness. So for example, on this part, as long as your inside bend radius is more than 0.06, you're fine. If you bend any sharper than that, you end up getting cracks forming because you're just bending it over too hard. Personally, I like to do my bends at like 2 to 3 times the material thickness. And then you never have an issue.
So as far as the final project, so when I was looking into like Stirling engines, like I noticed they were different like kinds of ways to make it. Like what kind of type do you think would be like the most suited for like the parts that we have?
I mean, really, you should be able to make most of the common types with what's in the baggie. Like if you do a walking beam, you might want to get some foam board, something like that, or a couple of popsicle sticks. I have that kind of stuff at Crosby if you can get to Crosby. In your case, I would say just choose something that you don't have to spend a lot of money on, unless you really want the thing as a showpiece after the fact.
Okay, and as far as like getting the parts, are you gonna like mail them out, or have you decided like what we're gonna do like for that?
Yeah, I only have like maybe 10 people out of 100 that can't get to Crosby. So I'm just gonna drop them in a little box and mail them off to you folks.
Okay, do you know when we should expect to like get them?
So the deal is, as soon as you show me that you've got a fully designed model, and you know exactly what shape you're going to make everything, what size you're going to make everything, that the displacer's not banging through the cans, then I'll say great, and I'll send out your stuff, or you can come get your stuff.
Okay, cool.
Yep, I'm just trying to reinforce that idea of we plan and then we build.
I have a quick question.
Yeah, Logan.
I know that you said that, like at the beginning of this class, that we already had the soda can modeled out for the homework. Was that like a required thing? Because I thought like we were just supposed to like design 3 or sketch 3 like objects that we had laying around.
Yeah, I did the same.
Yeah, so the deal was I wanted to see you draw a soda can and 2 other objects that you had laying around.
Okay. What is gonna be the like? Because I didn't catch that. I guess I just drew 3 objects. Do you want me to?
I mean, as long as you gave me 3 objects. I was pushing you to do the soda can simply because it's not lost work.
Right. Yeah, I understand that. I didn't catch what you said, I guess.
Yeah, I'll tell the graders if you just did 3 objects. Yeah, fine, whatever.
Yeah, I did the same thing.
Okay.
I did the same thing too.
Oh, you guys.
I didn't know how in detail you wanted the soda can. So I did most of it. I did like basically the general design of it, but I couldn't get like you know, the extra divot, like the extra ring that goes lower around the edge of the top of the can.
Yeah.
Yeah, I didn't put that in because I figured that wasn't necessary. It's not like a major thing.
Well, I mean, let's take a look at what is major.
So I was thinking I could also show mine too.
Okay, so here's my layout.
You know, I was talking about like the inside the top of the can. I did the
Yeah, so the top of the can, you're going to have to cut away.
okay, so it doesn't matter then. Okay.
Yeah, there's nothing that critical up there. However, on the bottom of the can, getting that geometry right is important for how much room you have for the displacer to move.
Ooh, okay. That means I need to. Okay.
So yeah, you need some pretty good fidelity down here.
All right.
So my can, when I did this one, I mean, my can is not super hyper accurate, but this is what I have. You know, don't worry about the little opening tab, forget about that. But you know, I do want to see the lip on top. This is the amount of detail I put on the bottom of my can. And I was quite fussy about the arch in the bottom of the can. And
How
I'm
did you
really,
find
then I'm really fussy about the distance from this edge up to this edge, because that's going to affect clearances of other parts.
Could I show mine?
Absolutely.
Because my issue is I don't have that bottom arch in.
I mean, that would look pretty good if you threw a couple of fillets on before you shelled it.
Yeah, but the issue is I don't have an arch here. I don't have that indentation. Because I couldn't quite get the measurements on it.
Yeah, so what I was telling people was just put a flat edge across the bottom of the can and then just put your ruler down in as best you can.
Get the maximum depth and then just try to.
Yeah.
Is there any way to modify this now that I've done this, or do I have to pretty much work backwards, do a
Yeah,
cut revolve?
Let me show you how I did it.
If you take the cell out, do a cut revolve, and then put the cell back in, I think you will fix it.
Because what I did was I had started off just by making a cylinder and then cut revolving multiple times.
And that's exactly what I did. So I've got a cylinder. I cut revolve the top on. I cut extruded that down and lost points. Mouth opening. Cut revolve on the bottom.
I saw that you did that, so I did that too in mine.
Yeah, so I lost points. That means you have to lose points.
Sweet. Love losing points.
I don't know why you guys want me to keep them. The department will get me more.
Oh, so
you can take my points. That's fine.
Okay, so I'll add. Okay, I can do that.
So yeah, this is the Revolve sketch that I did. And the only thing that was really kind of important, I put a horizontal construction line right here, and I made this 3-point arc tangent right at the center point, so I didn't end up with any little divots.
Okay, so yeah, I could just go back in. That's not a very big thing. I could just go back in and
yeah, it would look
fix
a lot.
That revolve cut.
Yeah, it would look a lot nicer.
Then it also gives me the room that you're talking about.
Yeah.
Okay. And I
have a
do need to
question
figure
about-
out how to get the labeling on there because I like that labeling.
We're going to go through that. They changed them.
Appearances. There it is.
Yeah.
Yep.
They changed the menu on that one. And it's this weird thing where you got to go under edit. You got to do some other stuff. But I did put the Coke can scanned label in there. And that's under the photo rendering lesson.
Sweet.
Could you send us those dimensions for the bottom of the can?
I think it was only 0.3 for the maximum depth.
That's what I've got at the moment. Yeah, 0.3. And you may want to check this because admittedly, I drew this one afternoon when it was cold out and I was just kind of doodling.
Is that what you do with your free time? You just play around in SolidWorks?
No. I have a barn with 12 antique Jeeps in it, all in various states of repair.
I see you're a Jeep guy.
Yeah, I'm on the 12 Jeep process trying to get over my addiction.
I'm delivering firewood with a 1972 Ford.
All guys have to have toys. Well, all geeks have to have toys. I won't even say guys anymore because my work study, she's a huge pickup truck girl. So, okay.
I had a quick question about the homework.
Yeah, Sam, go ahead.
I couldn't find that carbon steel material
Okay.
in SolidWorks. I just put 1010 and the only thing is the hot rolled bar. Just
Yeah,
normal steel.
that's fine. As long as you get the number right, that's the important thing.
Okay. And do you mind if I share real quick? I just want to.
Absolutely.
One thing.
It's all yours.
Wait, so do I have to do a hole? Do I have to do a blind hole wizard to actually instead of that extrude on the can?
No, you can absolutely do an extrude. So you're talking the mouth opening?
Yeah.
So what I did is I cut extruded an ellipse. And there's nothing in the hole wizard that's going to give you an ellipse.
But why would there be an ellipse when it's flat on the inside of the...
Because you're going to do a shell and you're going to pierce through that mouth opening. Oh yeah, that's pretty.
So my question was just for this. Where is it here? I got the dimension. Oh, wrong one there.
Don't forget your 0.10 gap.
Yeah, I have that.
Yeah, that looks about like 0.01.
So I dimensioned this with the right dimensions, and then I just did a linear pattern for it.
Perfect.
But I couldn't. There's no sketch associated with this, which I thought.
No, there's not, and that's the beauty of it.
Oh, okay. So that's only for the linear pattern inside the sketch function.
Correct.
Okay.
Yeah, that's why I love linear patterns so much, is there's no sketching, no smart dimensioning. You don't have to go through any of that foolishness.
Okay. So does this look fine? I mean, I think you mentioned about the dimensions. I've just measured them with the measure, and it looks fine. I didn't have to do anything. I just, right from my original sketch, I just put 4 and 3, and it seemed to work for me. But
so when you made your sheet metal flanges, you probably had one of the options set so it automatically cut it back. And that's totally fine. That's absolutely good. As long as it's dimensionally right, I'm happy.
All right, perfect. Thanks.
Yep.
I have a question about the sheet metal on the homework. How do you get your measurement for thickness to be in gauge instead of inches?
So that's where you use the sheet metal tables.
Okay.
Yeah, the sheet metal tables automatically set your material thickness.
And which table was it again that we're using?
Use the one that says steel air bending. That's the one that's closest to just laser cut it and go bend it on the sheet metal brake.
I have a question.
Yep, go ahead.
Do you think I could share my screen real
It's
quick?
all yours.
Okay. I just feel like my gaps are too big. I'm not sure if they are. They just look like it to me.
Yeah, you got something funky going on there.
Because on the edge flange, I put it as 0.01. So isn't that what you're supposed to do?
Yep, that's the right number. Absolutely.
Should I change the flange position maybe?
No, I think that's fine as well. So if you actually measure it, what's the width across the outside of your part? Hit the green check. There you go.
Like with a smart measurement, or I can't remember how to find the measure tool.
So hit evaluate. There you go. And then measure.
So from
Okay. So what you can do, you have two options. You're at 3.866. You can either decrease the width of your initial sketch by 0.866, or you can go in and change your bend options. So if you go under edge flange, go up to the very top one, right click and edit feature. There you go, good. Okay, go down to where it says flange position.
Yeah.
And try the second one in from the right. Yep.
Yeah.
Say okay, now measure it. Let's see what it gives you.
3.826.
So I would try a couple of those different options, and it will probably narrow everything up just like it did for Sam. Otherwise, your option is to simply go into your initial sketch where you drew the rectangle and then just subtract off 0.866 from the width. Either way is fine with me. So come down to flange position. Try the second one from the left. Okay, that went in the wrong direction.
Yeah, I don't know. I made the sketch how big it should be, so I don't know why it's doing that.
It's doing it because it's adding a bend radius to the outside of what you already had.
Oh, okay.
Plus it's adding two material thicknesses outside of what you already had.
Should I just try to edit the sketch itself?
You're welcome to do it that way. That's totally fine too.
So So get rid of 0.96 or 0.986.
And you can just literally type in minus 0.986 after the 3.
Minus 0.986.
There you go.
Yeah. So, wait. Was I looking at the wrong dimension the whole time? Because the bottom one says 2.134. Wait, I'm gonna undo that real quick.
So for that Excel error message, you're gonna look into it and get back to us.
I will, yes. So plan on seeing a message from me sometime this afternoon.
Okay, great. Thank you.
So should I add what 0.014 going this way, going vertically, and then subtract 0.12 from the width? Is that
Sure.
what I should do?
Yep.
Okay.
Oh, wait a minute. On the 3.986, that's not going to the outside. What is it actually to the outside? So if you go back and look at the print, I went to the outside edges.
Is that not the outside edge?
No, it's not.
Oh.
Not for the full height of the part.
Where should I select it then to measure it?
So you want to go to the 2 outermost edges, side to side and then up and down. All right, that looks good for the width. So yeah, take off 0.12 in width.
And add or no, minus 0.12.
Yes.
Okay, so it's 0.12. Minus 0.12. That's
Nice.
3. And then that's 4. Okay. Do you think it messed with the inner hole sketch thing? Or do you think that's fine?
It depends on where you dimension the start of the holes from. My guess is you're probably fine.
Yeah, it looks like I'm fine.
I'm a little surprised you didn't do a feature pattern, but I mean, that works too. Your method is legit.
Okay. I'll check it one more time. Maybe it's there. Yeah. All right. I think I'm good. Thank you.
Okay. All right, guys, if you're all set from here, I'm going to call it and end the Zoom call. All right, catch you later.